Bit of a pitch session. We've got startups here that our analyst team recommended you all learn about here today, and so they're here today with short presentations, so you'll get some visual aids, and hear from startups really from the whole energy storage supply chain ecosystem. We've got hardware, we've got software, there's some technology and some basic technology, and then some systems. So I think it's a great cross-section of what's going on in innovation in energy storage. And I think it's one of the things I really appreciate about this part of the clean energy market in general is that there's still lots of room for innovation. There's still lots of fundamental material science all the way up to advanced logic and software around managing battery systems. So it's a really dynamic and interesting startup ecosystem. There's still venture capital coming into it, R&D dollars coming into it. And lots of opportunity. It's still an early market, as you've been hearing for the last couple days. So I'm excited to be here. I'm Scott Claventa, the founder of Greentech Media, and now part of Wood Mackenzie's Power and Renewables division. And delighted to have my gang here today to share with you their presentation. So how this is going to go is they're each going to come up. They're going to get 5 minutes to do a quick presentation, just tell you about their companies, where they're at, what they're trying to solve, and then you'll have a minute or two to ask questions of each one. So use the same gtm.cnf.io webpage to enter any questions. I'll get those up here. I'll ask them real quick, and we'll go on to the next. And then at the very end, there will be a poll. So imagine yourself with $1 million and just vote for the one where you put that money down, and I will let them know who gets virtual $1 million, unfortunately. All right, let's jump into it. We're going to go alphabetical by company. So Rick Chamberlain from Cadenza goes first. I'm going to sit up here and try not to make you nervous.
That's fine. Great. Well, it's great to be here. I'm Rick Chamberlain, Vice President of Engineering at Cadenza. It's an honor that Greentech Media invited us to present a little bit about our company. So let me tell you what we're doing in the lithium-ion space. We've developed a new technology. We've got a team of people that's been working in lithium-ion for decades. And we recognized that improved safety is a critical need in the industry, especially as lithium-ion starts to scale to larger systems. So we developed an improved safety lithium-ion technology. We recognized you have to do that at low cost. If you don't have low cost, the markets aren't going to grow. And we also recognized if you can achieve this improved safety technology idea that we had, you can actually package the higher energy density. So improved safety, low cost, high energy density, these are the fundamental pillars of lithium-ion technology. And that's what Cadenza Innovation is all about. So how do we do this? First, we have a great team of people. We have an expert team of scientists working to develop the technology and validate the technology. We have a network within the lithium-ion industry with suppliers, material suppliers, technologists, academics, research labs, manufacturers of lithium-ion cells and batteries. And we leverage that network and that large team to produce the new technology. We partnered with a lot of specific entities, particularly funding from the U.S. Department of Energy ARPA-E program that really got the company going, allowing it to develop the technology and validate it. And by leveraging our network, we were able to do this relatively quickly and successfully. So what is it we're doing? Here's what we're doing. Here's our cell. What you see is a large lithium-ion cell. We currently have a product out there that's 83 amp-hour cell, so relatively large lithium-ion cell. And we're accessing jelly rolls. This is what you would find inside a typical 18650 or 2170 type cylindrical wound cell. We're leveraging what is the lowest cost lithium-ion cell technology available, but we're putting that together into a large format array, and we're doing that safely. And the way we do that safely is we've developed a housing. We call it a housing. It's the black material you see here. And what this does is it isolates those smaller energy units, those jelly rolls. And if there is a safety event in one of those jelly rolls, and that happens from time to time, that's established in the market, this housing prevents it from propagating. So it prevents it from propagating to other jelly rolls in the single cell. It prevents it from propagating to other cells in your battery, and it prevents it from propagating into the whole system. So if you have an issue, it doesn't turn into a big issue. It's a manageable, safe issue. And this is very important, again, as you look at large-scale systems. In addition, we had to put that all into a working cell, and so we had to develop a lot of the architecture around that to make it work. What markets are we going after? Automotive markets. That's, of course, a big market, and that's been driving applications in recent years and helping to drive down costs. So we've got programs in the automotive market, talking with automotive OEMs to make this work. Grid, of course, very important, very large, and we think it's a great fit for our technology. We're also into specialty segments, industrial applications, lawn and garden type applications. Where are we as a company? We've done the proof of concept. We've proven that it worked. We've gotten validation by outside labs, by third-party customers. We've got a foundation. We've got patents established to protect the technology. We've got demonstration projects that we're working on to demonstrate in a real working level how the technology works. And now we're working with partners to scale, to get to a scale where we can really demonstrate this in many applications. So we've recently announced a relationship with BAK. They're our first licensee of the technology. They're a well-established global supplier of lithium-ion cells, and they're our first step to getting to that commercial scale. So they're a great partner, and we just announced this in September, and we're working with them now to scale the technology. We've got an application to an energy storage system. We're working with New York State in a program funded by New York State to demonstrate a 200 kilowatt-hour unit in White Plains, New York, and that will demonstrate our technology in a grid application. And that's due to be up and running by the end of next year. We demonstrated, this was through a Fiat Chrysler Automotive project, part of the RPE work. We put our batteries into an automobile, into an EV, a Fiat 500e, and we could drive it around and prove that it worked for an EV application as well. And finally, I'd just like to reiterate that we had to leverage a lot of our partners to develop this technology and to make this work, and we're very thankful for all of their support to make this happen. And thank you very much.
Perfect timing.
Yeah.
Hit it right on the head. Thanks. I don't see a question here yet. Feel free to send one in. I guess one question I would have is if you were back here this time next year, where do you think you'll be? What's like the milestone you'd like to hit by December 2019?
Yeah, it's a great question. I would like to say we would have established a reasonable scale manufacturing location to scale the manufacturing into a number of different applications. We've got the energy storage unit going into White Plains, New York, so having that installed and demonstrated, that would also be another great milestone. I would also say maybe another licensee established would be good, so maybe those are the top three that come to mind. Yeah.
Are you out raising money now, or have you done that?
We are actively doing that. I think we're in pretty good shape, but we are actively doing that, yes.
Okay. So our virtual $1 million will help?
Yeah, well, we'll always take that. Never going to say no to that.
All right. Super. Wait, let me take one more like this one. Wait. What is the cycle life of your cells?
So the cycle life of our technology will match the chemistry that's in the jelly roll. So the safety technology we add has no impact to cycle life. So the cycle life is going to match what is as defined by the chemistry of the jelly rolls, and so that it can vary depending on which jelly rolls we're putting inside there. So
you're chemistry agnostic then?
We're chemistry agnostic. Our current product uses an NCM cathode, but we can use lithium iron phosphate. We can use NCA. The technology could adopt any of those chemistries. Okay,
and the note about the propagation and managing that through the unique kind of system there, would you say that's the main differentiator, or
I think,
how else do you talk to
yes,
customers?
The safety is the main differentiator. I think packaging, the packaging itself, it takes a low-cost commoditized jelly roll into a prismatic cell packaging, which is much easier to then build into large-scale systems, so that there's a packaging element there as well.
Okay, super.
All right.
Thank you very much. All right, next up, life cycle. There you go.
Thank you very much. Good afternoon. My name is Ajay Kochar. I am the CEO and one of the co-founders of Li-Cycle, and we are a closed-loop lithium-ion battery recycling company. And before I launch in here, I'm guessing in the audience that there are some folks here who have questions such as, what is the cost of recycling my lithium-ion energy storage system at the end of life? Who can do it? Is there a value associated with that? These are the questions that we're getting every day increasingly. We recognize this is a growing area of focus, and that's exactly the area that Li-Cycle is focused on. But first, let me focus on what the problem is with the recycling piece of the supply chain. This is a very simplified view of the lithium-ion battery supply chain, and it really centers around the way that lithium-ion batteries are recycled today. And that method is predominantly thermal. And when I say thermal, another word for that is pyrometallurgical. And essentially, the core issue here is that you have low recovery. What does that mean? That means that you have higher cost of recycling, and unfortunately, that cost is passed on to other parts of the supply chain. So at end of life, you have a high cost to actually recycle, and you actually don't get a lot of the materials back to then offset the cost of production. The core message is that this cannot work moving forward. I think all of us know in this room that there is a tsunami of spent lithium-ion batteries on the way from this space and many others, any space that lithium-ion batteries touch. And this is exactly the loop that Li-Cycle is closing through our technology. So as I mentioned, closed loop, what does that mean? It means that we can push recoveries to 80 to 100%. We have achieved this from lithium-ion batteries, agnostic of chemistry, form factor, application, prior use. And really the core value proposition here is to push recycling into, hopefully in the future, to enable that lithium-ion batteries could be value positive. At least neutral, but at hopefully value positive, and that's part of the vision here. And ultimately, that will incent higher recycling rates and make this into a true closed loop. And that is our core mission. So clearly my background image got removed here through being integrated, but there was an image of the pilot behind this. But look, a couple of data points here about what we're up to. We right now have an operating 1 ton per day pilot plant. The core message here and often question is, does this work? It works. That pilot plant is a 1 ton per day facility, so 1 ton per day of lithium-ion battery input. Coupled with that, we have substantial market traction. I think we've seen a lot of momentum behind this, and this is very encouraging. We have 5 master services agreements with automotive OEMs, growing into the battery OEMs as well as automotive through a variety of evaluation programs. We have 11 of those ongoing. And really the core proposition here, coupled with the recovery, is low cost. And our advantage is through a tailored process for recycling lithium-ion batteries, which has not been the case to date. So this is a view of where we've been and where we are. We are in our 3rd scale-up phase. So that 1 ton per day pilot I mentioned is in that 3rd column there. To date, there's been about $6 million US has been invested into Li-Cycle, about $8 million Canadian. We are Canada-based currently, but focusing on our next step now, which is a commercial facility. When I say commercial, I mean economically viable to recycle lithium-ion batteries, which has often been a dig against lithium-ion battery recycling to date. And that facility will process 5,000 tons per year of lithium-ion batteries, about 17 tons per day. We're actually in the midst of raising a Series B. About 65% of that subscribed so far, but if there's interest in that, feel free to talk to me. And I think the core message here as well is the global DNA. We have a vision here that this is needed for this space. To contextualize some of the numbers here, perhaps in terms that may be a bit understood better, 5,000 tons per year is 1 gigawatt hour. Okay, so that's just the tip of the iceberg of this industry. We're very fortunate to be supported by a fantastic team. Myself, I'm a chemical engineer by background. Come from the lithium and energy metal space, executing capital projects that were multi-billion dollars in scale. Tim Johnson is our chairman and my co-founder, comes from a similar space, also CFA, and very fortunate to be supported by folks who have business coupled with financial, coupled with project execution acumen on our board of directors as well as our advisory board and our executive team. So in summary, what is our value proposition? We are developing and have developed an industry-leading technology that is mechanical and hydrometallurgical in nature, hydrometallurgical meaning wet chemistry in nature, that can recycle lithium-ion batteries to recover up to 100% of the materials within. And that is an improvement on the existing incumbent technologies that are thermal. What's the value proposition? We can reduce the total cost of ownership for these batteries and improve project economics. And we're led by a team that has done it before, that's both technical and business. Thank you very much.
Super. All right, you guys are being great with time, ending right on the 0. Okay, so there's a couple here about value. What is the value of the materials you recover per 1 ton of battery? And then sort of the second underneath that, is there significant value of a lithium-ion battery at the end of a 10-year life cycle? So you want to just kind of dive in maybe a little deeper?
This is really chemistry dependent and volume dependent, I'd say. On a weighted average, if we can get up to just theoretical 100% recoveries, any chemistry lithium-ion batteries, we calculated about $3,000 to $8,000 a ton of residual value that could be recovered. So we're going to move there. It's going to take time and scale, and I think the key caveat there is that it's dependent on chemistry. So when we start talking about moving towards value positive, it's possible. But if we're in the first inning of energy storage, some would say recycling hasn't even started, but I'd argue that you have to start developing technology now for that.
Okay. Next one, what is the yield of reusable raw materials per ton of input? And how will this yield increase over time, given variability?
Good question. So our core value proposition from a recovery standpoint is enabling 80 to 100% yield. When I say that, I mean it both in terms of mass and functional material. So 1 ton of batteries coming in, coming out, and then be able to reuse in the economy, and also the functional materials like lithium, cobalt, nickel, manganese, et cetera.
Okay. Here's a good one. Why hasn't this been done before? What's the secret sauce?
So scale, I think, has not been there for this industry to date, and economics. And so the thermal technology that I mentioned to date has really been a general style of facility that's being leveraged for this purpose. The dollars have first not been invested into recycling lithium-ion batteries, but two, this is hard. There are a lot of challenges with lithium-ion battery recycling, be it electrolyte management, solvent recovery, electrolyte salt, thermal runaway prevention. So I won't go into it, but it's hard. So I think that's the other reason.
The next one, what is the impetus for recycling lithium-ion batteries? For example, no heavy metals. Does it require policy to be viable?
Very good question. I think what we see here is in China, for example, this year, August 1st, they enacted regulation, actually not legislation, that requires EV manufacturers to recycle their batteries. Europe, this is a bit more clear. North America, not as clear. I think policy can certainly be a force multiplier. I think it's jurisdictionally dependent. But in our view, recycling has to work on the baseline economics. This cannot be something that needs to have subsidies to really be viable moving forward. And it's possible. And that's my core message based on the core material value.
Okay. Quick question on the business model. Is it selling recovered lithium back to manufacturers or a service agreement where manufacturer agrees to buy back lithium? What's the relationship?
Yeah, so right now we provide services to OEMs, and essentially cost and liability are the key current focuses. The materials that we recover, we then sell back to the market. It's often a couple of steps removed from the battery cell manufacturer. Going forward, to answer that question, say 10 years in the future, is that closed loop arrangement possible? Absolutely. We just need skill to get there.
Okay. Perfect.
Okay, thank you very much.
All right. Thank you. All right, next up, Net Energy. All right, you guys are doing great with time. Appreciate
specifics. My name is Mike Pintock. I'm the CEO of Net Energy. We're a thermal energy storage company based in Chicago, Illinois. I'm excited to tell you about how we can help solve a huge problem in the commercial energy market. And that is that peak electricity for cooling is very expensive. Peak electricity for cooling is often 2 to 6 times more expensive during daytime on-peak rates than during less expensive off-peak nighttime rates. And in addition to this, there is often a demand charge that represents 50% or more of a commercial customer's energy bill. And building cooling is the primary driver for these high energy prices. But currently, there is no great solution to help combat this. So this is our Black Ice technology. This is a thermal battery that stores cold. Some of you may be familiar with ice storage as a technology, where you freeze water at night when the prices are low, use it during the day when the prices are high. We do something very similar, but we have a patented phase change composite of wax and graphite that has material properties that significantly improve the performance and allow us to integrate and be used in unique ways. First off, it has an optimal freezing point of about 40 degrees Fahrenheit, which significantly increases the efficiency of the air conditioner. And secondly, it has a very high thermal conductivity, 10 times higher than water and ice as a storage medium, so it can fully charge or discharge in less than 1 hour. And then lastly, it works as a heat exchanger, so you can integrate it with a single speed compressor and an air conditioner, but provide variable speed cooling. So the way we integrate it is if you want to think of a hybrid car where you can take a normal combustion engine, downsize the engine, add an electric motor, an electric battery, and it becomes 50% more efficient. something similar, you can take a 5-ton air conditioner, downsize the compressor to, say, 3 tons, add our thermal storage solution, and you reduce peak electricity consumption from the compressor by 40%. So overall, it has significantly improved performance. With just a 4-ton-hour thermal storage battery, we're able to provide 2 kilowatt demand reduction over the peak period. And this is very important, as we were discussing earlier today, is demand charges in the United States are very favorable. There are 5 million commercial buildings in the United States that are eligible for demand charges of $15 per kilowatt or more. This represents well over 10 million commercial air conditioner replacements in just the United States alone. And utility tariffs are trending towards more and higher demand charges across the country. And not only can the end user benefit, utilities can also benefit from our thermal storage technology. Everything from peak generation deferral to transmission and distribution deferral, demand response, and dynamic control of the grid. So a little bit about our product comparison. If you see there on the left is the minimum standard baseline air conditioner. There's a lot of information here, so we'll focus on the price. That price to the customer is about $3,000. In the middle you see is the highest efficiency air conditioner available, and that's about $6,000. Our hybrid thermal storage system will come in at about $5,000 while providing the benefits of the variable speed system with the addition of storage and peak electricity consumption reduction. So all this leads to is unit economics is a payback in 3 to 5 years without incentives when comparing to a baseline system, which is what you want in this industry. But it also has future eligibility for 3 types of incentives. Your general energy storage incentives, 1. Number 2, specific thermal energy storage incentives. And number 3, air conditioner efficiency incentives. So this can all lead to immediate payback and help drive initial adoption. And the further optimization will reduce payback to below 3 years. So overall, to any investors here, this is a very attractive market, $8 billion commercial air conditioning market in the United States. And globally, this is a $30 billion market beyond the United States. It's very fragmented, where no OEM has more than 13% of the market, and they're looking for different technologies to differentiate them. And a 1% market share leads to just $500 million of enterprise value. So our go-to-market strategy is we are working with 2 Fortune 500 HVAC manufacturers to help commercialize and develop our technology. We're also partnered with the National Renewable Energy Laboratory in Golden, Colorado. We are testing and developing our technology. And we're going to establish the initial go-to-market strategy with them. Our initial customer will be commercial buildings in the United States, with our growth customer is residential buildings and international commercial buildings. We have a great team of partners. My business partner successfully launched a lithium-ion battery company over a decade ago, and we have great partners like EPRI, Wells Fargo, University of Chicago, and others. So in terms of funding, we have received $1.2 million in funds. Almost all of that is non-dilutive grant funding with a few competition winnings, and we're raising a $2.5 million seed round, of which $1.5 million has been committed, which is perfect for the $1 million virtual prize.
Top it off. All right.
All right, so that concludes our presentation. I'd be happy to answer any questions.
Super. Thank you. Okay, good question at the top here. Do you have a solution to determine optimal charging times depending on local energy rates? Is there like a software, or do you rely on building energy management?
Yeah, we're developing that in conjunction with NREL. You know, the load profiles and the cooling needs are very different in Southern California versus New York State versus international. So that's just something that is managed within the controls of the air conditioner. What's kind of unique about our system is it can be more encapsulated in the air conditioner without relying on the building management system, where you have to take into account all of the components. It's more of just the air conditioner can provide that steady state peak demand reduction.
Okay. And there's a few comments or questions in here about competition. You describe yourself relative to the kind of established air conditioning systems. How about other thermal energy storage and that kind of thing that are in the more startup phase? What's the key differentiator there?
Well, the key differentiator is our material, the phase change composite material that has a very high thermal conductivity. So we're not trying to build, to put it back to the hybrid car analogy, we're building a hybrid car with a very small battery that reduces the cost of our system, rather than trying to build a fully electric vehicle with a very large battery. And in terms of cost and weight and size and placement, this allows it to be integrated with those smaller rooftop air conditioner systems and residential units that you don't see with other storage mediums.
Okay. Next question. can you describe how this could be either retrofit or does it come in new with an integrated smaller system, the way you displayed the economics early on?
Yeah, that's a great question. Our path to market is to build this at the factory with our OEM partners. So like a hybrid car, it will be integrated at the factory rather than trying to retrofit an existing vehicle to create a hybrid car or retrofitting existing air conditioners. Technically, it can be done, but from a go-to-market strategy, we don't view that as the best option.
Okay. What are the durability impacts of the modified duty cycle on the base air conditioning unit? And what is the lifespan of core? So how do those relate to each other?
Great questions. So the duty cycle should be improved because the air conditioner compressor will cycle less. It will turn on and off less, and that's when you have most of the mechanical wear and tear on the system. And in terms of the phase change composite material, unlike electrochemical batteries, it doesn't have a degradation over time because there isn't a chemical reaction. It's merely just a phase change.
Okay. All right, 20 seconds. Have you looked at applying these benefits to battery cooling? For example, charge the cooling when charging the battery and then take advantage of lower parasitics during discharge. Have you looked at, is there any relationship there that you've explored?
There's ways that they can be integrated and complement each other.
Okay. Well, there you go. Good stuff.
Okay, thank you.
Thank you. All right, Seppion Technologies. Peter?
Hi, thanks for the introduction. I'm Pete Frischman, CEO of Seppion Technologies. I took this opportunity to speak with you today for two reasons. One is to share with you some of the exciting products we're developing to improve batteries. And secondly, really to encourage the experts of the utility industry to think deeper than the systems level when considering solutions for grid-scale energy storage. The world is changing fast, with renewables plus storage beginning to eclipse the price of traditional solar or fossil fuel energy generation. So while simultaneously demand for electric vehicles is forecasted to surpass the demand for combustion engine vehicles in the next 15 years, a development that will dramatically impact how we use electricity on the grid. Now, battery breakthroughs are necessary to make both of these bullish forecasts a reality. Today's lithium-ion batteries are reaching a performance plateau, and energy-dense and safe technologies are needed. Most of these solutions today require expensive retooling of existing manufacturing. This is where we aim to help. Now, to be clear, Seppion is not a battery manufacturer. We are a materials company that specializes in ion-selective membranes that improve the safety, the energy density, and the cost of batteries. Now, many of you are probably thinking, well, how can you do that with just a membrane? I'll answer that, but first, what is a membrane anyways? Simply put, a membrane lets through the things you want and keeps out the things you don't. Most of us use membranes every day, from making a cup of coffee in the morning to keeping you dry in a rainstorm. Now, you may not know this, but nearly every single battery requires a membrane. The lithium-ion battery industry alone demanded 11 billion square feet of battery membrane last year, representing a $1.5 billion market. And still, these membranes are not quite good enough. Where poor battery membrane performance is tied to reduced lifetime of the battery, and worse yet, serious safety issues. So why does this happen? To understand, let's dig a little deeper into how a lithium-ion battery operates. Here's a simple depiction of a lithium-ion battery charging, where lithium ions are moving from one electrode to the other, and in doing so, are crossing through a membrane in the center. Under the demanding conditions of today's lithium-ion batteries, such as fast charge or the integration of new energy-dense electrodes, unsafe dendritic growth of lithium metal can lead to catastrophic failure of these batteries. And Seppion is here to help. With our membranes, we have pores so small, only ions smaller than a single nanometer are able to cross through the membrane material. And it's this ability to sieve ions at the atomic scale that is really at the core of our technology, and precisely this ability that opens up opportunities to make better batteries. Practically speaking, we coat a micron-thick layer of our proprietary polymer membrane onto today's existing battery separators and substitute a lithium metal anode for graphite to deliver a roll-to-roll scalable product that increases the energy density of today's lithium-ion batteries by 30% at a competitive price. Now, Now here's some data showing fast charging of a cell. This is 7C charge rate, so this is essentially charging an entire battery in under 10 minutes. You can see in black the baseline membrane undergoes a catastrophic failure, a shorting mechanism after only 60 cycles or so, whereas the cell with the Sepion membrane material lasts out beyond 150 cycles stably and then fails in a much more gentle, slow capacity fade. Importantly, our products are Gigafactory compatible, designed to integrate with existing lithium-ion infrastructure, manufacturing infrastructure, in order to reduce the barriers to market entry. Our business model is based on 3 core tenets: build a robust IP portfolio, rely on scalable capital-light outsourced manufacturing, and then monetize our products through direct sales or licensing. We are currently developing membrane products both for today's lithium-ion batteries, but also for next-gen lithium metal batteries, as well as ultra-low-cost flow batteries for the grid. I spend a lot of time engaging across the battery ecosystem to understand the needs of our customers and partners, particularly with automotive manufacturers, in order to generate a market pull scenario for our products. Today, we have 2 joint development agreements with battery manufacturers. We've raised $4 million in non-dilutive grant funds. We have $2 million committed to our $3 million seed round. And as we speak, 5 Tier 1 automotive manufacturers are testing our products. Now, my pitch so far has been classic entrepreneur. Everything is awesome. Come work with us to change the world. Let me tell you about something that is not working so well. Engaging with the utility industry. So I've had conversations with many of you, and they're great conversations, but they pretty much always end in the same tune, which is, it's really interesting what you're doing, Pete, but we're really focused on batteries at the systems level. And I respect that. You're all busy, and you have to prioritize. But today I want to end with an ask, and that's a request from the intellectuals of the utility industry gathered here today to get together to really answer 2 key questions and share that information publicly. Now, these questions seem simple on the surface, but require a lot of effort to unpack. And that's, how will batteries support the future grid? And what are the key performance and cost targets? By answering these 2 questions, you will empower entrepreneurs to help you build the grid of the future. At Sepion Technologies, we're selling advanced membranes, we're capital light, and we're targeting high growth markets. I'm Pete Frischman. Thanks for your attention.
All right, thanks a lot. Okay, couple questions so far. What is the impact on efficiency?
There's a lot of subtleties in that question. With our lithium metal anode product, we are operating above 99% Coulombic efficiency. With the lithium ion product, it's comparable to today's existing lithium ion cells.
Okay. Another simple one. How much cost does this add in dollars per kilowatt hour?
So with the lithium ion product that we are developing, the cost is actually lower because we're helping enable some of the more energy-dense, high nickel content cathodes, so alleviating the need for cobalt in many of these battery chemistries. In the lithium metal case, our cost model suggests that we'll be on parity with lithium ion.
Okay. This time next year, if you're back, where do you expect Sepion to be?
So I envision in the next year we will sign some pretty significant joint development agreements with key players in the industry, both automotive as well as battery membrane manufacturers, and that will be helping us move towards purchase orders. One of the challenges of this industry is the validation cycle for batteries is very long, and we're going to need to be working with partners for some time before product is really moving in the market.
Okay. And how about the impact on thermal stability?
I think I would talk to, was it Cadenza? So we do not spend too much time looking at thermal stability.
Okay.
That's more of a pack level issue. But the low resistance of our cells reduces the amount of heat generated during the high rate charging and discharging.
Okay. Super. That does it. All right.
Thank you.
Thank you very much. All right. Voltaic. Going to end on software.
Yeah.
All right. I've heard it all.
Excellent. Thanks for having me, Scott. So I'm Tal Scholklopper. I'm the CEO and co-founder of Voltaic. And what Voltaic is, it's a battery intelligence software platform. And you may ask, why do you need a battery intelligence software platform? We have, the battery itself, we have the battery controls, the BMS, the EMS for these systems. We see a need for a layer on top of that to actually analyze those batteries and see how they're doing. Pete actually hit the nail on the head talking about these validation cycles. We're taking these same lithium-ion batteries in our cell phones and laptops and now asking them to last 10 years or longer to really make the economics work for these projects. And that's where Voltaic comes in. We're a platform really designed to look at the battery system specifically and dive in and see how that battery is actually doing and find performance issues well ahead of there being actual safety issues or early returns on those systems. So the company got started in 2012. We brought together a group of not just battery scientists like myself, but also software developers and data scientists. What we realized is that with all of this data, we're either seeing companies come in and have battery developers actually try to make their own software, which wasn't scalable or robust, or software developers come in and develop software solutions to try to bring in this data, but not be able to extract any of the meaningful metrics. So we've really brought that together in one house. Our customers, we have customers like Pete at Sepion. We have a number of larger customers on the OEM side of things as well, working with a number of large automotive OEMs, both in Detroit and Germany, as well as Uber and Proterra here on the West Coast. Grid-scale energy storage starting to do more work as well. Consumer electronics working with the large Fortune 10 customers and their consumer electronics divisions, as well as working deeper into the supply chain with OEMs and suppliers. Offices around the globe starting to actually set up some more operations in Asia as well, in addition to our offices here in the US as well as in Germany. So what I really want to share to you today beyond the, just what the vision is and what Voltaic is really focused on is really the opportunities to leverage some of the best practices from those other industries in this energy storage arena. There's a lot of things that could actually be used to really ensure those project returns that we're looking at to make sure these things provide those IRRs that developers are looking for. And so very quickly, the battery data doesn't just start when the system gets installed and put into the ground. It actually starts with the early stages of research and development. It's the materials that go into the battery when it's manufactured, its processing parameters, its quality assurance. All of that really goes into how a system is going to operate in the field. Voltaic provides a layer on top of that ingests this data, automatically harmonizes it, put it all into a common language so you could actually do a common analysis across batteries from all kinds of different systems, whether it's different vendors like Samsung or Panasonic, or all the way going back to the manufacturers in Asia. Bring that all into a common platform and a common language, and then do a whole range of battery-specific analytics on that data. All of that goes into a database, and then we have a front-end application that makes it easy to surface that information and learn from it. So shifting to the energy storage sector, the returns in these projects are incredibly dependent on the batteries. But it's been a little bit surprising as we've gotten deeper into the sector, the lack of attention on some of the key metrics that affect these projects. First, we break it down to really 3 areas here. One is supplier transparency. The other side is commissioning and sizing, and the rest is this ROI uncertainty. Starting with the suppliers, there's a reason why these automotive companies send supply quality engineering teams. Consumer electronics companies do it as well. There's a reason they're sending them to Asia. You actually need to track your supply chain. You need to ensure that you're getting good batteries that are going into your products. You need that to ensure not only safety, but also the longevity of these systems. The other challenge is, a lot of these systems right now are still designed on a spec sheet that you get from a manufacturer. That is a use case that was, idealized in the lab. What you're actually going to be using the battery system for in the field often varies a lot from that as well. And so you need to start having that information more information to really make good decisions on how the system is going to be used in the field. One of the other challenges we've seen on commissioning and sizing is, it's good that these companies are actually speccing out these oversizes of the system. The problem is we're seeing that actually mask a lot of underlying problems with the batteries and commissioning and integration. And then ROI uncertainty. A lot of these battery systems, the use cases are still variable. And we need a lot more information to really make sure that these systems are going to meet the ROI targets long term. And so this is the way we like to look at these battery issues at Voltaic. This is actually from, Mike actually brought this up on the mechanical lens, this wear and tear type failure that happens. Mechanical engineers call this Weibull type analysis. And so if you look at something like a spring, like a door on a car, you end up using it multiple times, and all of a sudden you start having this statistical failure that starts to happen in the devices. So what we see here is a plot with the y-axis is the failure rate, and then the time or life cycle for the device is on that x-axis. This is the ideal scenario. This is what you expect to see in most of your devices. Unfortunately, when it comes to battery, we have two other issues occurring. One is this, what they call infant mortality. The mechanical engineers are very morbid. You end up having a lot of these early failures associated with manufacturing issues and quality issues. And so we see those same issues when we're looking at actual grid-scale energy storage systems we've tracked in the field as well. And so you need to be able to spot those batteries before you actually install the system. That could ruin your entire project economics right there. The next issue we start seeing is this variable usage. Not only is the usage profile that you're designing your system for hasn't been tested by the battery OEM themselves, you may actually change that over time. That may very negatively affect the actual life cycle of the system as well. Again, negatively affecting that return on investment for the project. And so where Voltaic comes in is on all three of those areas, we could have a large effect. We actually start off with that supplier transparency, actually tying in very similar to what we do with our OEM and our automotive and consumer electronics customers. You need to make sure you have a good battery going into the system. It all starts right there. The next stage is to make sure you're not overpaying for batteries, make sure you're buying the right amount of batteries for your system. And then beyond that, even in our early work with tier 1 battery OEMs, we're seeing 30% of batteries that have issues in these systems. And so this is low-hanging fruit. This is ultimately what's going to make or break the returns on these projects. And it's really important to actually take that step back and not just try to get these systems into the ground cheaply. It's also making sure that you have the data and confidence in these systems that they're going to meet their long-term lifetimes that you're requiring for the project returns. So with that, I'll open up to some questions. Thank you.
All right, super. Just a quick one on your path to market strategy, how you're planning on entering with this layer of software or this type of software.
So to date, the majority of our customer base is in the product engineering sector. So it's working with customers in the R&D stages as well as OEMs in the validation, pack design, and BMS design for the systems. We are getting pull from those same customers and their partners, both upstream and downstream. So we're starting to do more work in Asia with the battery supply chain as well, and have started to track systems in the field with larger energy storage operators and utilities.
Okay. And what's just the key message to project developers or asset owners why having this element of software makes a difference for them? How do you get through?
I think the key is just making sure that you understand, taking one step back, it's really about just making sure you have good batteries in the system and you know how they're performing. It's not just that performance optimization. If you look at the industry right now, it's very centered on cost optimization and making sure you get the returns from the system. And so you have that good short-term focus, but beyond that, that doesn't matter if the system doesn't last long enough. And so making sure you have good batteries and making sure you're not damaging them or doing things to them that are going to negatively affect the lifetime becomes critical to really ensure long-term health of those projects.
Okay. Quick question, what is the infant mortality rate in batteries that you mentioned? Is there a kind of an industry rate that you've seen so far? Or?
So it varies from battery to battery. What you often see happening is when things are accelerated or people are trying to decrease costs too quickly without validating these batteries, you end up with early battery failures. So one of the most famous ones was the Galaxy Note 7, where Samsung was trying to rush a product out to market and didn't qualify it properly. And so you ended up seeing these early fires in the system. Most of the time, it isn't that dire. Batteries are probably one of the highest causes of early warranty returns for products. And so depending on the product and if it wasn't properly designed and qualified, you may see up to like 10 to 20% returns on some of them.
Okay. Can you elaborate on the trade-off between sorting out defective cells and higher quality cells?
We don't think there's much of a trade-off. If you look at the automotive industry, they are able to get cells and batteries and other components for their vehicles at low costs. It just requires that attention to detail and someone really making sure that process is done properly.
Okay. All right, there's our time. Thank you.
Thank you.
Great job. Okay, that was great. So now here is your chance to vote. It says favorite, but let's stick with my virtual $1 million you're going to award here today. It's GTM coin. We just minted cryptocurrency, and here's your chance to award it. All right, I'll give you a minute to keep voting, and then we'll have our storage finance panel come up. All right, you can't see this, I can. But it looks like, actually everybody did quite well, so congrats everybody, but Li-Cycle came in number 1. Congratulations. Spend your GTM coin wisely. All right, thanks. Let's move on to the next panel. I appreciate it. One more round of applause for the startups.